Welcome to a new AG session all about analytic geometry. We are to show that a point 5, 2 is on the perpendicular bisector of the segment connecting A at 1, 3 and B at 4 and -2. Now, there are a lot of things in this given item and we need to talk about them one by one. Of course, we need to illustrate it first here in our Cartesian plane. Let us start with the point 5 and 2. Our horizontal axis is our x-axis, and let's say each of the grids are per 1. So we have here 1, 2, 3, 4, and 5. And then 1 and 2. This is the point 5 and 2. We need to show that this point is on the perpendicular bisector of a segment connecting the other 2 points. So let's have point A here. Let's label this as point C later. Let's start with point A, 1 and then 3. This is point A. Okay, this is point A. Next is our B, point 4 at 4 and -2. 1 and 2. 4 and 2. This is our B. If we are going to connect these 2 points, we will form a line, or let's just say a line segment here because that's what is only given here. So line segment AB, and it says here that this point 5, 2, as I mentioned, let's call it as point C, is on the perpendicular bisector of this segment. Now there are 2 terms here, perpendicular and bisector. This means that if we're going to come up with a certain line, okay, a certain line from this point to this segment, it must form a 90-degree angle on its intersection. And at the same time, for it to be called bisector, the intersection of the line containing C and the line connecting A and B is actually the midpoint of the segment AB. Okay, so let's say something here. We're not yet sure if it's here, but let's just say it's there. So if this is the case in this given, this C, 5 and 2, is a perpendicular bisector. Hence, we are sure that the intersection here must be at 90-degree angle. And this point here, okay, whatever point is that, is the midpoint of A and B. Now, how do we determine this? Now, again, there are a lot of things in this given item. Let's start with the idea of bisector. Okay? We are going to examine first the midpoint of A and B. Okay? To solve for the midpoint, okay, of segment A and B, the formula for that is equal to this one here. You have your x sub 1 plus x sub 2. Divide it to 2 because it's a midpoint, but since it's a point, it's a combination of x and y coordinate. So we have the other thing as well for our y value. Now we are just going to input here the values of x sub 1, x sub 2, y sub 1 and y sub 2 to solve for this point here. Now after solving for that point, we will be solving for the slope of these 2 points. And of course, we know the relationship of the slope for this segment and this segment for them to be called perpendicular. But let's start with the bisector. Let's say our A is our point 1. So our x sub 1 and y sub 1 belongs to point A. So we have here 1 plus our point B is our point 2. So we have 1 plus 4, the x sub 2 of our item here, divide by 2. And you will have here our y sub 1. We have 3, which is the y value of point A. And you have here plus -2. All over 2. Okay? So the midpoint of line segment AB is the point at 5 halves. No need to come up with a decimal notation or mixed fraction. And we have here positive 1 half. This would mean this point here, let's say again, let's call it point D. This would be our point D. Okay? Let's call this the midpoint of segment AB being our point D. has the coordinates 5 halves and 1 half. Now, after solving that, this point here bisects this segment. Okay, that's why we started with bisector. This means that if this line segment is drawn from point C, our 5, 2 earlier, this is 5, 2, okay, the given, and connecting here at point 5 halves and 1 half, this segment bisects AB. So we are now done with bisector. The thing now here is, since we already have the bisector, let's show the relationship between these two segments in terms of their slope. We know that for the two lines or two line segments to be perpendicular to each other, the slope of the first line is equal to the negative reciprocal of the other. So let's solve for the independent slopes of both, so that we could satisfy the idea of bisector and perpendicularity. So first is for the slope of AB. The slope can be solved using this formula, the change in y sub 2 minus y sub 1 over the change in x sub 2 minus x sub 1. Again, we chose earlier b as our point 2, so our y sub 2 is negative 2 minus our y sub 1 is 3. But either way, if you are going to interchange a and b as point 1 and point 2 respectively, just make sure that the y sub 2, the value of y sub 2 and x sub 2 would go together over. And even if you're going to interchange this formula here, make sure it should be y sub 2 first, x sub 2 first before the sub 1s. And of course, the sub 1, we have the x sub 2 is 4 minus x sub 1 being 1. So the slope of AB, okay, there's the slope of AB is equal to negative 5/3. This is the slope of this segment AB here. Now let's try to solve for the slope of segment CD. The original point C, to which we are going to examine if this is part of the line segment that is perpendicular bisector of AB, and D is the midpoint. Because, again, to satisfy bisector, the line segment should pass through the midpoint. So we have satisfied that. We're just going to satisfy now the perpendicularity. So let's show the relationship of the slope of CD against AB to meet this. Okay? So CD, let's have C as our point 2, point 1 in this case, and D is our point 2. So having the same formula, y sub 2 being the y coordinate of our D minus our y sub 1 for C, which is 2, over our x sub 2, which is this here 5 halves, minus our x sub 2, x sub 1 rather, because that's our x sub 1. Again, we pick point C as our sub 1, so that's why we have y sub 1, x sub 1, and this will be our point 2. Now, this is a little bit complicated because we have fractions, but of course, we just need to apply the necessary operation involving rational numbers. So, we could combine this as LCD. Let's start with the numerator first. 2 divided by 2 is 2 times 1, 1. This has denominator of 1. Any integer can be written as a fraction of denominator 1, just like this 2 and 5. So 2 divided by 1 here is 2 times 2, 4. Minus. Our denominator will also have a denominator of 2, LCD. 2 divided by 2 is 1, times 5 is 5. 2 divided by 1 is 2 times 5, I have here 10. Minus. So we have here negative 3 halves for our numerator over negative 5 halves for our denominator. Now we are dividing fractions now, so we're going to use here the keep change flip method, which tells us that we keep the first fraction, okay, or the rational expression. Instead of division, we're going to multiply it, change. So keep, change, and flip. We're going to reciprocate our denominator or our rational expression or our fraction on our denominator. It's 2 over negative 5. The cancellation law of multiplication, 2, 2, and a negative, negative. The slope of CD, the slope of CD, okay, is 3 halves. 3 fifths, rather. 3 fifths. Positive 3 fifths. Now this is the slope of CD, the line segment connecting the point 52, which we coined as point C, and the midpoint of segment AB we labeled as D. Look at the relationship between the two slopes. Okay? We have here the they are just simply reciprocals, more specifically negative reciprocal, because if we're going to take the negative reciprocal of this, so we are going to multiply this by negative and we'll reciprocate that 3 over negative 5. The answer is 3/5. If this would be subjected to that negative reciprocal, so negative and reciprocate that 5/3, we'll just return to this as well. This would mean that this satisfies the condition that the line segment AB and the line segment drawn connecting point C at 5/2 and the midpoint of AB, D at 5/2 and 1/2 are perpendicular to each other. This is the proof that point C at 5/2 is on the perpendicular bisector of the segment connecting A and B, because D is right at the midpoint, hence it bisects AD, and the slopes, as mentioned here, satisfy the condition for perpendicularity. Thank you for watching, and stay tuned for another session here in AG for Analytic Geometry.